welcome to the Azure Latam community. Feel free to start over when you're ready.
Yes, thank you, Dave. And I think it's super nice to talk to a Mexican community. I think it's super fun. Actually, it's not so late here. It's 5 o'clock in the evening, so it's totally fine. Even later would also be great. I work at, or we start maybe. I really like Azure API Management, basically because I've worked a lot with Azure API Management the last couple of years, and also Microsoft noticed this, but more about this in a second. Just try to, so. The very boring stuff first. I work for Vipps. Vipps is a mobile payment. It's you can send money from a friend to another friend. You only need the telephone number. You can pay invoices there, and you can do all your payment stuff basically with this Vipps app. It's basically an app on your iPhone or Android phone, and you're good to pay anything. In 2020, the brand recognition is almost 100%. So we are in Norway pretty famous. Almost 70% of all Norwegian are using it. That means not the children, of course, and not the super old people either. We have about 3.8 million users, which is maybe not super much, but it's everybody who can and is allowed to pay in Norway and does this with us basically. And you have to remember we are a payment service, super boring stuff basically, but we are more loved in the population more than Netflix and Spotify and YouTube and stuff like that. So I think it's a great service. What I wanna tell today is what Azure API Management basically is. I'm not sure if some of you already are familiar with Azure API Management, but I will show you how it works basically, and also tell about some use cases, architecture, and what you can do basically with it. And Azure API Management is also somehow a bit weird in some cases, and I think that's super important to know about this, because everything stands or falls with this concept, which is a bit weird in my opinion. So first of all, I take this back here away. First of all, Azure API Management is just an API gateway, right? You have your clients, for example, an app, or you have API developers that would love to use your services. They connect to Azure API Management, and then those requests are routed towards your services. And those services can run in Azure Kubernetes Service, or in functions, or serverless, or Azure Web Services, or maybe also services that are outside of your Azure account tenant. Maybe running on Amazon or whatever. It doesn't matter for API management really where it is. But the good thing is really that you have one layer where you control all your users and your APIs, and what's underneath or in the backend, that's really not important. The essence of Azure API Management is to hide the backends basically. You can compose buckets basically of APIs or bundle them. For example, you have some APIs that are great for payments that just a subset of your users are allowed to use, so you can bundle them into or group them into products basically, and make them as accessible only for those users. You can mock APIs with Azure API Management. You can also do throttling, for example. That means you can say my payments API, or I have users that send requests all the time, and I know that a payment only can occur for one user once in a minute, for example, so you can control that. You can transform requests or outputs from XML to JSON or whatever. Authentication, you can trace everything, and you have basically everything accessible in Azure API Management. But what you also can do is super easy onboard your users. So you have lots of APIs and your users want to use them. Azure API Management has a developer portal that comes out of the box that you can brand with your corporation design and onboard very simple users basically as a self-service. We'll maybe also look into that. So I already told a bit of the use cases. You can monitor APIs, identify errors. You can look into the utilization of your APIs. You can bundle APIs into products and stuff like that. But we will look at that in more detail. What we use API management in WIPS for is composing APIs. So as I told, bundle them into products. We have, for example, a merchant product that has a lot of APIs that only the merchants are allowed to use. And we have the same for payments and then some more. We do some throttling, so rate limiting, so that not too many requests goes into the backend, just to protect it a bit. And we do very limited access control in API management. We basically don't want to do anything in API management at all. And there's a reason for that, but I will explain a bit later when we go into the depth and details, really. I thought maybe at first, for those that don't know Azure API Management yet, we just take a look at it. So I have prepared it here already. I make it a bit larger, like this. So we have it here. So first of all, I have this is the usual stuff here. I have an overview with some URLs and resource group. But here I have all my APIs. In this case, I have just an Echo API, so basically nothing. And but here's how I can access my APIs. And I can take a look here, Echo API, and this Echo API then contains a lot of endpoints. In API management, we call them operations. So I have a post here and a put and stuff like that. We can also test them. We have some settings and so on. And here on the right side, that we will all explain or deep dive into a bit later. But here we have policies where we can change the behavior of APIs. That means I can, for example, do all those rate limiting, or I can say that today this API is routed towards AKS or on-prem, and now I've migrated my microservices to AKS, and now I can change this this routing in those policies on the right side here. Then I have name values. Name values are basically just key value pairs. So I can store, for example, the AKS URL there that I then can use in policies. Then I have subscriptions. Subscriptions means basically my users or the clients of the APIs can subscribe to this API, to APIs or products that contains a lot of APIs, and those subscriptions are handled here. Here I have my products where I bundle my APIs. And then I have users here where I can have all my users that are allowed to use my APIs. I can group them and stuff like that. So this is really the important stuff of API management. But we will figure out how those works and where the problems really are a bit later. So this is, I think, the most important part of Azure API Management. This is super simple to understand, but when it comes later to policies where we really write some code, behavior, then it's often very hard, my experience says, that to relate to this picture again. So first of all, I have my endpoint and my service API, my API, and this API has endpoints. They are just there. All my service APIs or my APIs are just there. In VIPS, we have about 100 APIs, and they are just flat there. And then we bundle them into products. In this case, we have, we have Web Services and Merchant Services. They have just subsets of all those APIs. And on the left side, I have then my users that can subscribe to products. Today, it's also possible that users can subscribe directly to APIs. That wasn't possible a year ago. But I'm not sure if I could recommend it, because all those subscriptions and users, and if they are subscribed to products or API, it can get very messy very, very fast. So we'll get back to this picture when we talk about policies as well. About the pricing, we have, this is very interesting because when you are in production and you run a very critical business, you probably want to have great SLA. And we, of course, want this and need this. So we run premium, but premium is super expensive. But premium has the advantage that you have, you can put it into a virtual network, so you can have it internally, so not accessible from the outside. You can, of course, open it, but so you have it in a virtual network. And when you also develop your APIs and need to play in a test environment, for example, you would go for the developer tier. It's a lot cheaper, but there you have also the virtual network, but of course no SLA. The problem with developer and premium tier is if you just want to play around, it takes about 45 minutes to provision. So it's a very long time. So if you just want to run some tests or so and spin it up and throw it away, it's almost not possible. So that's why the consumption plan is really great. You have limited SLA and you have no virtual network, but you can play around with your APIs or users or subscription and stuff like that. And you can provision it in 30 seconds or so. So it's almost immediately there. But consumption plan, there are a lot of stuff that you don't have. It's really only for testing or for your hobby projects or stuff like that. And then you have basic and standard. They come with no virtual network, but they have SLA, of course, as well. Okay. So deployment options. If you want to deploy APIs or provision API management, there are a lot of possibilities in API management. I'm not sure if one of you have worked with API management. The easiest way, of course, is through the portal. You just can click you around or do ClickOps and you have everything. But you have no history, of course, then. And if you have the financial authorities also behind you that make sure that you all do everything right, you can't use the portal. Then, very popular, of course, is ARM templates. And we started Azure API Management with ARM templates. But this is really a problem with ARM templates because ARM templates are super verbose and it's super hard for developers to create APIs and then having also ARM templates. I tell more about this in a minute. Then you have the REST API, so you can just send REST requests. PowerShell. We use PowerShell because it's super simple. And then you have the typical candidates like Terraform and Pulumi and Ansible and stuff like that. So we will dive into API management very concrete, very fast. But I think this is very important, this picture here as well, even though it's super boring. But when we started with our APIs, we had all of our APIs in one repository. So in this case here, we have 4 APIs in one repository. And what you would typically do is when you make a change, you have, let's call it one monolith in this repository, you would commit it, deploy it to Azure API Management. And this works, of course, totally fine. But there are multiple problems. The first one is you have to have 2 Swagger files, one in this APIM repository and one in together with your application. And that you have to have in sync at all time. But the bigger problem really is that, and we had this, when you have a test environment and you have a production environment and you have maybe another environment, but let's say you have an incident and then you fix it in Azure API Management. You have to fix this, of course, also in the code where you that you want to deploy, but this time you did it directly in the portal because it's easier. You have to keep them all the time in sync. The test, the production, and your code. If you don't do this, and I will promise you, you will forget it sometimes when you have a lot of APIs like we have, and suddenly you are somehow out of sync. And we had this once. We had to add a new functionality in production, and I took over this project because another guy who was responsible for this had quit, so he was away. And now we had to, or I had to provision from the code base. But the problem is that the test environment was different than the production. So if I would just have deployed, I would have overwritten everything. So what I want to say is that I really didn't know what to do. Something would be overwritten and I would destroy something, but it was super hard. So what we did first of all, to split it up, that all those APIs only belong to the repository of the application. So you don't have the Swagger files twice. And then you can say, I just want to provision this API from this application to API management. So the first experience is really to not have a repository for APIM. Keep the Swagger files in the repositories of the applications and nothing more. Because I've seen very often that people have a one repository as we had, because Azure API Management comes with a Git repository built in that you probably just would clone on your machine and sync all the time, or commit and then make the changes on the fly. So it's super problematic. So on the left side is the APIM repository that we started with, and we started with ARM templates. So we have, in this example, 2 APIs, payments and invoice. And payments has, well, let's talk about invoice because it's more complicated. You have an invoice ARM JSON template. We'll take a look very soon. It's just verbose JSON code. Then we have a policy where we can change the behavior of an API. And we have a Swagger file, so the specification of our API. So since we also have endpoints can also have policies. So they can also change the behavior. So we can, for example, add a mock in this operation. So we have an XML file for that as well. So we have a lot of files. So first thing we did, we split them up, or we moved the code into the repositories of the applications. Nothing more. So it's just refactoring a bit. But the problem is those ARM templates. If we take a look at this ARM template here, we see a lot of code, and there's nothing that is really important, despite of where it basically is, all those files, the name, and then an API ID. So 3 or 4 informations are really important. The rest is just noise. So in order to avoid this, we really needed to get rid of those ARM templates. What we did, we replaced ARM templates with PowerShell, because PowerShell is super simple. We removed all those ARM templates from all repositories, so we didn't have them anymore. PowerShell for APIM has a great documentation. And I would just want to show you very simple how you can use it. If you have an instance already running, and we do some more practical stuff very soon, but you can, you would say, what's the context of the API management instance? That means what instance are we actually working with? So I need to give it the resource group and the name of the service, nothing more. So now in the context, it knows what it is. So now I would like to provision or deploy an API, which means a Swagger file. Instead of having this super long ARM template, I just can say, so this is the APIM context. The format is Swagger. The path of my Swagger file is in the specification path. Then I tell it also what's the context path. So basically your URL / and then the context path of your API, and just an API ID, so an identifier, nothing more. Then you get some information back. So basically you have then deployed an API and you are basically finished. And you don't need any ARM template. You can just create a pipeline in Azure DevOps, for example, or with GitHub Actions, and run this this import line. That's it. And that's basically what we did also. If you want to get it, just use the get functionality with the API ID, and then you get the same information back. And for policies, it's basically the same. If you want to set some behavior of an API or operation, for example. So I thought maybe I can show a bit at first. So first of all, if you deploy it, you just go into the portal and say create API management, and in what tier you want to have. In this case, I chose the developer tier, so I can show a bit more. Now I want to just from the portal deploy an API. So that's basically this Swagger file here. I hope you can see it, demo conference API, which has a lot of information there. So I can go just into APIs. Here it is. And then I can say open API. I chose that. I choose this, put in the information. I need a context path. I call it conf, for example. And now we have here this URL down there. That's the accessible URL at the end. Now I can just click create. And after about 10-15 seconds or so, it's available and fully usable. That means, of course, that the service behind needs to be running, but in this case, it is running. So I have all my endpoints here. I know that get topics, this works without any parameters. So now I can go into test, for example, and I can just send a test request, and then it works. So I get all my I get everything back, basically all those topics that I have or that are available. So if I would, let's just try out to send this here from the browser, because then you see it doesn't work. So why doesn't this work? this works, and this is also something quite critical to know why this works, not works, and why it works from the portal. In the portal, if you use the portal, it uses a subscription ID. Let me show you the subscription ID. Here's the subscription ID, OC APIM subscription key. And this key that you can see here is a master key. And you can't delete this master key. It's always there. So in order to make it accessible from the browser here, I need to set a header with this master key. So this master key is under subscription here, this built-in all subscription. If we make it, can I make it visible? Normally I can, there. So here's this subscription key. And since, as you see here, I can just regenerate it, but I cannot delete the subscription key. That means it's always there. And we had some incident once, or it wasn't maybe an incident, but we noticed that some developers that didn't know APIM so well, they were giving this master subscription keys to clients that are that were allowed to use just a subset of all APIs. So they could basically reach all the APIs that we had. So what we did to prevent this is to go into the policies, so where you can change the behavior of an API, and say whenever there's a request with this master key, then just return 404 or something, or internal server error. So this is something which is very important to know. So, but if I nevertheless just want to have this totally open, and I don't want to use a subscription key, I can go into settings here, and then I can say subscription required. No, I don't want that. I can save it. And then the entire API is open. So that means this here, that should work now, and it does. So that was this. I also can use PowerShell. As I showed you before, I don't need to run it right now because you have seen it, how it would work. If we would like, for example, to create a new API, we can also do this. Can create a blank API, give it a name, payments API, for example, right, payments, and then we can create it. And I can test it, but there is nothing, there's no endpoint, so it wouldn't work. But then I can create an endpoint. I call it just ping, for example, and the endpoint name is ping. Then I can save it. So this won't work yet, just want to show it to you. Because there is nothing, but I can, because I know, for example, that there is a service somewhere that it's not yet finished, but I want to mock it. So I can go into the policies here, there. We'll talk about this a bit about later, about policies, but let me just add, oops, I didn't want that one. Go into ping here, add policy there. So we can just add, for example, a mock and return a 200, and we save it. And if we test it now, send, we would get back 200. So this way I have implemented something. And I want to show you what I actually implemented here. That is in the policy. Sorry, for ping. I can see that we'll talk about policies a bit later, but I have a mock statement here. And this means I can basically add anything in policies. Just one thing, it can get critical because this policy you see is XML code, but I am free to use .NET Core, maybe .NET 5 very soon, but that means I can code C# inside XML. And this is, of course, totally messy and super hard to maintain. But it is possible, and also in VIPs, we are doing it. And as you will see later, it can get very, very, very messy over time. Okay. Yes. Now let's talk about who can actually use this. Now I have an API, and I would like, for example, this demo conference that only it requires a subscription key, and of course not the master subscription key. I have to prevent this in a policy later. I want this certain users can use this. And the way we can do this is, first of all, we need to have a user. So let's just, I'm some weird place now. Let's go into there. Let's first of all create a user. I have just the administrator here, but let's create a real user, Sven Malvik, FNID, like this. Now my user is incorrect values. Probably not that, but okay, once more. It does already exist, yeah, of course. Sorry. Take my son. I should read first. Okay, here's Sven that has the email address even at malvik.de. And now I have a user. Now I want that this user can subscribe to a product. So first of all, I need to have a product. Because as I said, we don't subscribe to APIs because it can get very, very hard to maintain over time if you have a lot of APIs. So we have products. We go into product and then we create a new product and we call it conference. And it is published and it requires subscription, and we just create it. We just write something here. Now we have a conference, but we forgot something. We have to add APIs to it. So we can just go in here and add APIs. And now I will say the demo conference API is okay, not the echo, but the payments is also okay. So now we have a product with those two APIs that are available. Now I want to make them accessible for this user. So now I have to create a subscription. Can go in here and just add one subscription. I call it Sven Malvik to payments, and allow tracing. I can say all APIs or some certain APIs or product. I chose a product, and then I use this conference product that I just created. I have this user here. this conference product, and then I have the subscription key. So now I have, if we go back where we were, I have a user, which is Sven Malvik, that has a subscription to a conference product, which has two APIs in his product. So that means if I would test it, I can use, for example, Postman, for example, but I can also go into the test plane where I were originally. But first of all, I need, of course, to have the subscription key. I can make them visible. I can copy it here. Then I can go into APIs, and then I want to test this here, for example. Get topics again, because I can't use get this one probably right now because it requires a subscription. No, I can still, because it has the subscription here. It shouldn't. No, it was this one here. Sorry. This was the original one. It was this one here. I can't access it. So that means if I need to have a subscription key, and this requires one. So if I go here and choose get topics again, and I go to test, I need a header. I need a header. Here's my value. And I choose this one here, like this. Yeah, I could also have chosen the product, but now I should send it, and then it should work. I get a 200 back. So this way you can control what user can use what API. And this you can code with PowerShell, of course, as well. Okay, let's move forward. Policies. Policies, they can do access control, you can transform your responses, you can do caching, you can do header validation, mocking, and monetize maybe your web services as well. There's a lot of things that you can do. Basically, you can do anything you want because you code C# in XML and you have .NET Core available. So there's huge flexibility, but this is since you have XML and C#, it's super messy, and it's not really fun at all, because it's almost not possible to code this well. I mean, there are VS Code, as a Visual Studio code extensions for that, where you can have snippets and paste them in. This works, but it's still, you don't have this, it's of course not the same at all. But let's talk about policies for a moment. So you have on the left side the client, and on the right side the service. And in the middle you have APIM, and the core is really policies. And you have already seen 4 sections. You have inbound, backend, outbound, on arrow. So whenever a request comes in, it's treated in the inbound section. When it goes to backend, outbound when it goes back. And in case there is no answer from the service, so a timeout, the on error will occur. So there are many policies. There are a global policy, so one global policy that where you can code and it applies to any request basically, on product level, on API level, and on operations level. So that means, well, let me make this bigger here again. That means that here's the code for one policy. And you have, or we have 4 levels. so let's assume we have a policy in operation. So we have, for example, this ping in the payment, and we don't want to that users can use it more than 10 times a minute, for example. So you would basically have a rate limiting in operational policy in the inbound section. So it doesn't need to go into the backend, right? So you would code it in the inbound here. Then we have base. Base means that it will include also the policy from one level above. That means in this case, it's the API policy, where you maybe also have code. Maybe you want to trace something or do some logging, or you do authentication there or whatever. You can have code there. So that means you have the operation here. Then you have base, which includes authorization. And in this API policy, again, you have a base, which includes product, and this includes global. So at the end, you have a lot of C# code in XML. And this is hard to maintain, of course. So let me just show you this. So here we have the demo conference. So we have get topics, and in get topics, I will just add a mock here. So we have some code there. Now I go to get topics, and we go to all operations. That means now we are on the API level here. I can also add something. Let's just do IP filtering, for example. Add IP 102.0.0.1, just to have some code there. Good. Now we go one level above into the product. We go to the product, which is here. We have the conference API, and we have policies here. So let's just wait. Now we add, let's just add some comment, because I don't have any idea now. This is a test. So, and now, was this saved? Yes. We go back to the APIs again, because now we would implement some global as well. So now we go to all APIs and add something as well. We can, for example, set a header, test header, and value, add value and test value like this, and save. So now I want to show you how the generated policy for one request looks. We can go into the operation or the endpoint that we would like to test, and that was get topics, right? We can go to the right here, or go into the policy itself. And now we can say calculate effective policy. For that, we need, of course, to know what product we actually test. We know we are here in this operation for this API, but we have maybe many products. In this case, we have conference. So let's have conference. And now we see in this inbound, we have the test header with the value. We have our IP, and we also have this comment here. This is a tag. This is a test, and we have our mock. So now assume you have C# code inside here, and you have logging and a lot of stuff. That means the it can become very, very big. And we have policies in WIPs that are many, many hundreds of lines just because it's possible, and people didn't really know that you shouldn't do it. So we learned over time that don't put anything into policies if you don't have to, because nobody can maintain this over time. Okay. Yeah, here's an example, of course, of a policy with a bit of C# code. But this is not much C# code. You can have multiple lines and really implement stuff there. Maybe you do some check based on a response from an external service. So you would create a service call to the service, you get a response back, maybe in a weird format. You would need to transform it first and extract all those informations that you need to get a couple of lines at the end. But here's just an example that you can do stuff. For example, you can have conditions. You can store variables or create variables that are accessible throughout the request then. And you can pretty much do whatever you want. What we do basically on the API level is just set the backend service. So where is my AKS basically, in this case, based on a named value. You can do a bit more advanced mock, not just saying 200, but you can, for example, set the status and a header and a body and stuff like that. So that's those kinds of stuff we are doing in policies and nothing more. So we already have done some this task here. We have set up a mock and we have also set a header already. I could do the same with, we did actually IP filtering as well, very basic, just that you have seen it. Maintenance. I see I'm running out of time, but there's so much to tell about Azure API Management. Logging, for example, you have application insights. This is just a checkbox in the applications, in the API, sorry. Very easy, just have an instance of application insights running and do this checkbox, and it will send the information to application insights, very easy. But if you want to create policies and you want to log for debug, for example, I mean, this is super hard in API management, right? You can use event hubs for that. Event hubs, you create an event hub namespace, you create event hub in this namespace, and then you can create event hub logger. So basically, it's a few lines of code, and I have also described this in my blog previously. Not logging in Azure API Management, where you can do this. This is a tutorial. It's very, very simple, just a few lines of code, how you create an event hub and event logger. This is basically all the code that you need to create an event hub. At the end, all those things you can do in the portal, but what you cannot do in the portal is to create a API management logger. There you have to use PowerShell, and there you give it the API management context again, the logger ID that you have that you choose yourself, and a connection string to the event hub that you have gotten right before. And then you have an ID, and this ID you can use to create a log to event hub code snippet for your policy. And this is how the policy would then look like. Just a logger ID with the ID, and then you can put in the values you would like to log. Very simple. Then all those events or log statements for each and every request go to the event hub. And Azure API Management has created an Event Hub Explorer, which is super easy to use. You can just connect this with clicking in the portal in the VS Code, and connect it to the Event Hub, and then you can see each and every event which is coming in, like here. Azure Event Hub Explorer, message received with all those information that we have logged. I would like to show it as well, but the time is running out. Yeah, this there I would. Then we can run Azure API Management in internal mode and external mode. Internal mode means we have VNet, which is closed, of course. We have network security rules around, so nobody can talk to this VNet, but we can make it accessible through App Gateway, for example, or App Gateway. And that's how we did it, so that your API management instance is secured. That means internal services, AKS, can use this API management instance directly, but external have to go through App Gateway, for example. Here's this in this case with Application Gateway. But you can also provision it in external mode. That means it gets a public IP address and it's totally open and everybody can use it. At the end, this is super interesting, and I would also love to show you that one, but it's a bit hard right now. But imagine that you have an on-premise service that you would like to use, and you have some other service, and they need to talk to each other through API management. So you have API management is, for us, for example, in Amsterdam. We use West Europe. This data center is in West Europe. So my service has to, the request goes into API management, Amsterdam, so some 100 kilometers away, and then the service request goes somewhere else, maybe to Mexico City. Why wouldn't it be great if the request would go directly? And this is possible. You can have the API gateway as a Docker container and install it on your Kubernetes cluster, for example, and then they would talk directly with each other. Whenever you make a change in the API, and portal would automatically reflect then back to the instance or the Docker image that you have already running, which is super great. Of course, you have a port opening there, but all those changes are immediately reflected. Maybe to show you very, very fast, you can go into, it's called gateways there. Gateways, go to plus, give it a name, gateways allocation West Europe. Then you can add APIs, for example, the conference API and payment, for example, add them. And what you would get back then is this here. Go there under deployments, and here you get for Docker command, for Kubernetes you get all the stuff that you need, and you would now just need this environment file here that you would install on your machine, which has the public IP, of course, and the token, and then you would just run this command and it will work immediately. Yes, that was it from my side.
Thank you so much, Sven, and really appreciate your time today.